Last class, we were talking about what do you mean by rolling motion and what's the total energy in a rolling motion. So this is what we stopped. That is total energy in the system of a rigid body. In the rolling motion, we have already completed half m omega square into r squared plus k square. Now, suppose so far the previous one we are talking in the case of when an object is moving on a playground, like on a field. On a field, it is rolling, just like car wheels are rolling, tire is rolling. So that is the condition we have taken in this case. Now, inclined plane like that. When they come roll into inclined plane, you have already discussed in motion in plane. There's a possibility of resolving the components, correct? That is, one is the ball is coming down, one is what type of force is acting downward, children? In this case, what type of force is acting? Gravitational force is acting downwards. That means it is resolving into two components, mg sine theta and mg cos theta. And from that is the derivation starts. But finally, we are coming to a total energy of a body rolling down an inclined plane, mgh. That means object is now at a particular height. So the energy possessed by that ball at that particular height is mgh. That is why the word is mgh. Now what happened? It started now coming downwards. Then what happened? By looking into conservation of energy, this potential energy slowly converting into part of kinetic energy. But since it is a rotational motion or since it is a rolling motion, it not only have kinetic energy or translational motion, it also will have rotational motion. So that is the assumption we take it. Okay. So in the case of a straight line rolling motion, there is no point of resolving the components. There is no point of resolving the components. But in this case, the ball is at a particular height. At a particular height, it possesses maximum potential energy. Kinetic energy is zero. So that is why total energy at a particular height is actually equal to the potential energy. Then it started moving. When they started moving slowly, this potential energy converted into kinetic energy. But since it is a rolling motion, it have both translational and rotational motion. Therefore, in translational motion, energy possessed by body half mv square, and in rotational motion, energy possessed by half I omega square. Therefore, total energy when a body is rolling down an inclined plane is equal to, don't write now, you just listen, I'll give you some steps. This is final result. So, in a rolling motion, when a body is rolling down an inclined plane, by the law of conservation of energy, total energy that is equal to the potential energy at a particular height. After changing, after moving, that potential energy converted into kinetic energy of translational motion plus kinetic energy of rotational motion. So final equation is going to be mgh is equal to half mv squared plus half I omega square. Okay, that's about this rolling motion. So first we will just write some introduction notes, and then we come to the final equation. Okay, okay, write down. You can write down the same sentence: a body rolling down an inclined plane. Roughly just draw this figure. Roughly draw this figure. So the components here, it is mg sine theta. We just given sine theta, mg sine theta, and mg cos theta. So mg is resolved into two components. So we can write it at a 90 degree. So mg is here. So we can write it like outside. Mg cos theta. So this is our theta. So corresponding mg cos theta, we have normal reaction force here. What is the force opposite to that? Frictional force. So we are just ignoring all these components now. Just you write like that. Okay, consider, write down, consider, consider, consider a rigid body, consider a rigid body such as a solid cylinder, such as a solid cylinder or sphere. We just assume anyone. There's not a solid cylinder or a sphere rolling on a horizontal surface, on a horizontal surface in an inclined plane, in an inclined plane, inclined plane with a mass m, with a mass m, with a mass m, with mass m, and radius r, and radius r, with a linear velocity, with a linear velocity of its axis, with the linear velocity of its axis v, and linear with the linear velocity of its axis v, and omega as angular, omega as angular velocity of rotation, and omega as angular velocity of rotation. Let I be the moment of inertia about its axis of rotation. About its axis of rotation. The axis of rotation. Axis of rotation. Next line. The total energy possessed by the body, total energy possessed by the body at a particular height, at a particular height is equal to Potential energy is equal to mgh before rolling down. Potential energy before rolling down. When it starts rolling down, when it starts rolling down, when it starts rolling down, potential energy converted into potential energy converted into translational energy, translational energy and rotational energy, converted into translation energy and rotational energy. Therefore, total energy, therefore, total energy is equal to energy T plus energy R. Energy translational plus energy rotational. Then you can write this equation. That is mgh is equal to half mv squared plus half I omega square. Next line. Suppose the body is rolling. Suppose the body is rolling on a horizontal surface. Suppose body is rolling on a horizontal surface without angle of inclination, without angle of inclination theta, angle of inclination theta. In the case of a solid cylinder, in the case of a solid cylinder, in the case of a solid cylinder, I is equal to mr square by 2. That is from the table. The table what we have learned, that's why I told you have to learn that table whenever this object has mentioned. I is equal to mr square by 2. Then total energy is equal to half mv square plus half I omega square. That is equal to bracket we know. V is equal to R omega, where omega is equal to V by R. V is equal to R omega, therefore omega is equal to V by R. Then we substitute V by R in this equation, therefore half mv square plus half into mr square by 2 into omega square, V squared by R square. V squared plus, okay, this is also a small letter r because since we have taken radius as small r. So that also you write it in terms of small r. Small r, mr square into V squared by R square. So whatever we can cancel. We know that this r square and this r square get cancelled. And this is half mv square by half into mr squared by 2 means 2 into 2 is 4. So you are going to get mv squared by 4 and here mv squared by 2. And they can we can add both of them. Correct? So we can cancel r square. Therefore, total kinetic energy. Total kinetic energy is equal to half mv square plus this is mv square by 4.
We can cancel, right? Score.
We have done. I did not cut it because I told you to cut. If I cut, it become a mixed. I told you. Cut R score and R score. Finally, we are getting that is what I have written. Remaining what is MV squared by 4. Here, instead of half MV square, you can write it MV square by 2. So you can cut R square. Okay, I'm not cutting because it may be. Now take the LCM. Finally, what are you going to get? LCM going to be 4. Finally, what answer you get right? All of you. Simple, no?
3 MB square
Ah,
by
3 MB squared
4.
by 4. Therefore, total kinetic energy 3 MV square by 4. So this is the case if there is no angle. If there is no angle theta, we don't have to consider these components. Without components, we can directly apply the equation in this. Okay. So this is what is given in your textbook. For this inclined plane, we can just write the final answer. Same theory, but final answer because there is theta, everything is there. Okay. Now, those who finish, you can write in the case of, in the case of, in the case of body, in the case of body, rolling on an inclined plane, rolling on an inclined plane at an angle theta, inclined plane at an angle theta, at an angle theta, then the forces acting on the system, the forces acting on the system are, one is weight mg acting vertically downwards, vertically downwards. Second force, which is acting normal reaction force, normal reaction R, perpendicular to the plane. And third force, frictional force. Frictional force F, F acting tangent, acting tangent, acting tangent, acting, you can write acting tangentially, not tangent, acting tangentially to the plane upwards, to the plane upwards. Next line, since weight mg, since weight mg of the body, since weight mg of the body resolved into two components, resolved into two components, resolved into two components. Mg cos theta resolved into two components, mg cos theta and mg sin theta. Mg cos theta and mg sin theta perpendicular and parallel. Mg sin theta perpendicular and parallel to the plane respectively. To the plane respectively. Next line. If you look at the picture, perpendicularly means the motion is in this way. So that means at the perpendicular, we can consider there is no motion. The rolling motion is this way in the inclined plane. We can say horizontally along the inclined plane. There is no motion, upward or downward motion in that case. Okay, so we can consider there is no motion perpendicular to the plane. Both translational and rotational is along the horizontal plane, horizontal inclined plane. So we can cancel, we can consider there is no motion in that. So write down. Since there is no motion, since there is no motion, perpendicular to the plane. Since there is no motion perpendicular to the plane, we can write R is equal to mg cos theta. That is equation 1. R is equal to mg cos theta. And net force or total force. Net force or total force. You know why R is at mg cos theta. If you take it, R minus mg cos theta, you will get equation is 0. If you want, you can write because there is no net force. In that case, it is going to be 0. That's the meaning. So that is why we have written R is equal to mg cos theta. Next, net force or total force on the body. Total force on the body. Here we are considering cylinder. So let us take it that. On the body, bracket cylinder, acting downwards on the plane. Acting downwards on the plane. This way. Okay, according to the picture, it is pointing downwards. Therefore, we can write it F is equal to mg sin theta. What is there against mg sin theta? Frictional force. So you can write mg sin theta minus F. Frictional force is against the motion, so that is why plus become minus. Total is plus, but since frictional force is minus, you can write the equation mg sin theta minus F. That is equal to mass into acceleration by Newton's second law. Mass into acceleration. We can take it as equation 2. Now, coming to rolling motion. This is only linear motion. Thus, torque acting. Torque acting on the cylinder. Torque acting on the cylinder due to frictional force F dot R, small letter f. Why? Due to frictional force. This cylinder is rolling and coming this way. By the time friction was trying to pull it this way. So that is what it is given torque. So due to frictional force also there will be a torque acting on it. So that is why. Okay. That is equation 3. Equation 3. We also have torque is equal to, in terms of moment of inertia and angular acceleration, I alpha. That is equation 4. Because we require both translational as well as the rotational. That is why we are applying torque also here. Next line. Next line. We also have linear acceleration is equal to angular acceleration into r. This is a relation. We also have acceleration. Linear acceleration is equal to alpha into r. Alpha means what? You remember that d omega by dt. That is what? Correct? We have learned in the previous class. alpha d omega by dt. So instead of d omega by dt, I am applying alpha r. A is equal to alpha by r, and what is alpha? Alpha is equal to a by r. That is equation 5. Substitute 5 in 4. Substitute 5 in 4. Substitute 5 in 4. So you will get tau is equal to, instead of alpha, you can write I into a by r, equation 6. Equation 6. That means by combining, next line, by combining equation 6 and previous slide. Equation 3. By combining equation 6 and equation 3. By combining equation 6 and equation 3, torque is equal to I A by R, which is also is equal to F dot R. Equation is 7. Or find the frictional force here. Why are you doing this? Because we have got the equation, no? Mg sin theta. Here there's a one term is there. What is that? FF, one term is there. Net force. Here it is written, no? Minus F. Mg sin theta minus F. So from this equation you are getting value of F. For that only we are doing all this. So from this we can get it, or F is equal to, IA by R, which is equal to F R. So that will be equal to IA by R square. That's it. The F is equal to, F means frictional force. Frictional force is equal to IA by R square. That is equation 8. Now, by substituting, by substituting 8 in equation 2, 8 in equation 2, that is mg sin theta minus IA r square, that is equal to MA. Next steps we are not going to, because we don't want that. So we are now coming to the last point after substituting all the manipulation we do. And solving, you can end up, even if I ask in the exam also, you can end up like that, by substituting and solving. We get coefficient of static friction. We get coefficient of static friction. Coefficient of static friction. Mu s is equal to F by R is equal to, only this you study. We are not going for how we are getting. Mg sin theta by Mg tan theta. That is Mg cancel. Finally, you are getting coefficient of static friction is equal to mu s is equal to 1 by 3 tan theta. And acceleration is equal to
1 by 3 sin theta by tan theta.
Sin theta, sorry, cos theta. It's supposed to be cos theta. Sorry, cos theta. mg cancel. You will get finally 1 by 3 tan theta. And acceleration 2 by 3 g sin theta. And frictional force is equal to 1 by 3 mg sin theta. Okay. Thus, for a solid cylinder, or I mean to say, for a solid cylinder or a rigid body, rigid body, rigid body, rolling motion should satisfy, rolling motion should satisfy the condition, that is tan theta less than or equal to 3 into mu s. 3 into mu s. So if this condition satisfies, then we can have the total energy in terms of kinetic energy and rotational motion in terms of theta. Otherwise, we cannot satisfy without it. So usually in our daily life, inclined plane never comes in some certain cases only. Mainly the main cases what we have discussed before. That is rolling motion on a horizontal plane, that is equal to half I omega squared plus half mv squared. So that is the condition. So in this case, we need to satisfy the frictional force. Suppose we are ignoring frictional force, then naturally the total energy conservation can calculate a little more easily. So that is the one. So by this, we completed this chapter. So last period, we will do the problem using I omega, square I omega and all. Okay. So Friday, we will start next chapter. And children, is there any doubt regarding art integration project? Because this is also included. You already have done investigatory project. Art integration project is mainly for instead of record. So you are not writing record since we don't have lab anything like that. We supposed to submit a record. Some schools are doing record, but we are not giving you. So instead of that only, sir is giving you art integration project. So actually that chapter is basically chapter